Hello everybody, Namaste. My name is Anushka and I'm currently studying in Sri Venkateshwara College of Engineering. Today we'll be discussing about vector calculus. The agenda of this presentation would be to talk about vector calculus, vector fields, gradient, divergence and curl, and the applications of vector calculus in various fields. Introduction. Vector calculus is a branch of mathematics that deals with functions of several variables and their derivatives. It has many practical applications in fields such as physics, engineering, and computer graphics. In calculus, we use vectors to represent quantities that have both magnitude and direction. These vectors can be added, subtracted, and multiplied by scalars to create new vectors. By using these operations, we can perform calculations on functions of several variables and gain insights into their behavior. What is vector calculus? Vector calculus is a branch of mathematics that deals with the study of vectors and their various operations. It's basically is a tool in modern physics, engineering, and computer graphics. Vector calculus is also used to describe physical phenomena such as electromagnetism, fluid dynamics, and many other fields. Vectors are quantities which have both magnitude and direction, while scalar only have magnitude. Vector calculus involves the manipulation of vectors and their various operations such as addition, subtraction, scalar multiplication, dot product, cross product, and many more. These operations are used to solve problems in physics, engineering, and other fields. In vector calculus, we have two types of physical quantities. One is scalar, the other is vector. Scalar quantities only represent magnitude. Example is temperature of Mars. Vectors, on the other hand, are quantities that represent both magnitude as well as direction, such as velocity or force. Vectors can be added and multiplied by scalars. These operations allow us to manipulate vectors in various ways, which is crucial in many applications of vector calculus. For example, we use vectors to describe the motion of an object in three-dimensional space or to calculate the force acting on an object in fluid flow. Example of scalar could be taken as distance. 5 kilometers is distance that is traveled. It only talks about the magnitude of the distance traveled. Whereas 5 kilometer in east can be taken as displacement, which tells us about the magnitude as well as direction. Now let's talk about vector field. A vector field is a mathematical construct that associates a vector to each point in space. These fields are used extensively in physics and engineering to describe physical phenomena such as fluid flow, electromagnetic fields, and gravitational fields. One example of vector field is electric field surrounding a charged particle. The direction and magnitude of electric field at any point in space can be determined using vector calculus. Another example is the velocity field of a fluid, which describes the speed and direction of the fluid at every point in space. Now that we have understood what vector field is and what vector calculus is, let's understand gradient operator. The gradient operator is a fundamental concept in the field of vector calculus. It describes the rate of change of function with respect to its variables. It is denoted by the symbol del, and the gradient is used extensively in physics and engineering to describe the flow of energy, heat, and other physical quantities. For example, in fluid dynamics, the gradient is used to describe the velocity of a fluid. The magnitude of gradient represents the speed of the fluid at a given point, while the direction of the gradient represents the direction of the flow. Similarly, in electromagnetism, the gradient is used to describe the electric field and magnetic field around a charged particle or a current carrying wire. Now that we have understood what gradient operator is, let's understand divergence operator. Divergence operator is a fundamental concept in vector calculus that measures the rate of which a vector field diverges from or converges to a point. It is represented by the symbol del dot f, where f is the vector field and del is the del operator. While the divergence of a vector field is positive, it means that the field is spreading outward from the point. while a negative divergence indicates that the field is converging towards the point. One way to visualize the concept of divergence is to imagine a fluid flowing through a pipe. If the fluid is flowing into a point, the divergence is negative, indicating that the fluid is converging towards the point. Conversely, if the fluid is flowing out of the point, the divergence is positive, indicating that the fluid is spreading outward from the point. In this way, the divergence can be used to model the behavior of fluids in engineering applications such as fluid dynamics and aerodynamics, very important fields in engineering. The another important operator in the vector calculus is curl operator. It basically measures the rotation of a vector field. It is represented as the cross product of the del operator and the vector field. The curl has important applications in physics and engineering, particularly in fluid dynamics and electromagnetism. One example of how the curl is used in physics is in the study of vortices in fluid flow. The curl of the velocity field of a fluid gives the vorticity, which describes the local spinning motion of the fluid. In electromagnetism, the curl of an electric field gives the magnetic field, and vice versa. This relationship is described by Maxwell's equation, which are fundamental of our understanding in electricity and magnetism. Let's talk about application of vector calculus. Vector calculus is a powerful tool used in a variety of real-world applications including electromagnetism, fluid dynamics, and computer graphics. In electromagnetism, vector calculus is used to describe the behavior of electric and magnetic fields. Fluid dynamics relies heavily on vector calculus to model the motion of fluids such as air and water. And in computer graphics, vector calculus is used to create sophisticated visuals, effect, and animation. One example where vector calculus is used is airplane wings. Engineers use vector calculus to model the flow of air around the wing, which helps them optimize the shape for maximum lift and minimum drag. Another example is to analyze the weather patterns, where the vector calculus is used to model the behavior of winds and currents. These are just few examples where vector calculus is used in modern engineering and in conclusion, vector calculus is a powerful tool that has revolutionized modern mathematics and engineering. By using vectors to represent physical quantities such as force, velocity, and acceleration, we are able to better understand the world around us and make more accurate predictions about its behavior. Thank you. I hope this video was informational. If you like this video, please make sure to give it a big thumbs up. Until then, I'll see you in the next one.